Okay, so in the last video, we looked at DeepSeek and how the model works and stuff like that. In this video, I want to show you a little bit about how you could start using this now for putting into agents and for getting sort of structured responses out, etc. Since I made the first video, DeepSeek themselves have actually now added search on their website for using this model. So if you want to actually be able to use both the deep think and search, you can actually come in here and turn these on and use both of them at the same time. And you'll see that you get quite a lot of sites. Here it's basically looking for going through all these different sites in both English and Chinese in this case. But one of the biggest problems with this model, or one of the biggest challenges with this model, is just that currently it doesn't have support for a lot of these features like function calling, like JSON output, etc. It's basically just going to give you the response back, and then you have to do something with that response. Now, this causes issues with a lot of the ways that we build agents, right? We're used to being able to get structured responses back, doing function calling, doing all these kinds of things in there. So in this video, I'm going to show you some hacks of how to get around this and a few different ways that you can use this with Pydantic AI so that you can get started on actually incorporating this DeepSeek reasoning model into a structured agent use case, etc. Now, everything I'm going to show you here will also apply with the new Gemini 2.0 thinking models. They have the same issue, right? That currently they only support code execution in there. They don't have function calling. They don't have search and stuff like that. Now, all of this will change over time. They will basically work out how to fine tune function calling into this, how to get structured outputs out of this, how to get consistent JSON out of these models, etc. But for the time being, if you want to get started, you're going to have to bend the rules a little bit. All right, so if we look at the response that DeepSeek R1 gave itself for how to basically do the structured response, actually very interesting, much more than I thought it was going to be. So you can see that first off, it's saying try out just doing prompt engineering for this. And this, I think, will work reasonably well. I know, for example, the new Gemini 2.0 thinking model is also actually very good at giving out JSON responses and JSON formatted code, etc., even though it's not set up to force it to do this. The second one talks about a prompting framework for doing this. And then they also talk about some interesting things here about the API configuration for this. So one of the things I'll talk about when we look at the code is that actually one of the nice things about the API is that it actually gives you the thinking tokens and the answer tokens separately. So you can actually play around with that in there. Then it also mentions things like using the distilled versions of the model, which I talked about, last time in the previous videos, etc. And it's got some examples of doing, these kinds of things in there. Let's jump into the code and I'll show you a different way that you can actually do this kind of thing. All right, so if we come into Colab and you can see I'm using a sort of version of the old notebook that I used for doing search agent. And we might finish up doing some things with some kind of search agent to show things as well. All right, so I'm going to be using Pydantic AI for this. Now, really, even though I'm using Pydantic AI here, we could be using LangGraph and LangChain or Llama Index or a whole bunch of different ones. Fundamentally, the ideas are kind of the same. For this, really what I'm making use of for the Pydantic AI is just a really good way to get structured outputs. And this is often what I use Pydantic AI for. If I've got it in microservices or something where I just want something that I can swap out models quite easily, but I can get the same simple structured outputs from whatever I'm sort of putting into this. All right, you can see I was basically setting up the Tavili search, which I showed in a previous video. If we do a search for the DeepSeek R1, we can see we've got stuff in there, etc. And now we come to the Pydantic setup stuff. So the key thing here is that we're going to be using the DeepSeek API. To do this, they've basically got their API set up in the exact same way as OpenAI. So we can redefine the base URL for the OpenAI API here to be api.deepseek.com. And then we can set up two of these models. So I've got one, which is what they call the DeepSeek Chat model. So that's actually DeepSeek v3. That is also a really awesome model. It's actually a very strong model. And then we've got the DeepSeek R1, this reasoning model that we want there. And you can see I've got a key for doing this. And DeepSeek themselves have got a whole bunch of information up on their site about how to do this and showing you using the OpenAI SDK for Python and then also the JavaScript SDK as well. Now, if you come into their platform.deepseek.com, you can actually put in some money to use this, and you can put in just as little as $2 to use it. They've got stuff up about their pricing. So currently they've got it at a discounted price. It's going to go up slightly after the 8th of February. All right, so once we've got these two models set up, we can use these with Pydantic quite easily. First off, what I thought I'd do is just show you using the exact same sort of search agent that I set up in a previous video where we looked at this. In that one, we used OpenAI. So here I'm just swapping it out for the DeepSeek chat model. So this is the DeepSeek V3. And you can see that sure enough, we've got our search data class. We've got this research result that we want to get back. And these are what we pass into the Pydantic agent. So this sort of tells it what your dependencies are going in and also what we expect back as structured data coming back from this. We pass in the Tavili search tool. So this is just setting up the search tool, etc. And then we can pass in the date or other things like that. And then we can just run it to do basically a sort of search and running it through the agent here. So here we're basically got a query. Can you give me a very detailed breakdown of the DeepSeek R1 model? And so it first off goes off, and this is all just using the DeepSeek V3 model at this point. We're not using the reasoner model. We're not actually using the R1 model itself at this point. But you can see that, okay, it's conforming. The DeepSeek V3 model just works nicely with our structured outputs from Pydantic. We wanted it to go off and come up with 3 to 5 different search queries. It's done that. It's come back with model architecture, model training process, model applications, performance benchmarks, etc. And then it's returned it back in this nicely structured thing where we've got our title, we've got our research main, we've got some research bullets and stuff like that. And you can see if we go through these, we can print these out and they're all coming back in nice markdown. And in fact, if we just join them all together and print them out, we can see, sure enough, we get a nice little report about the DeepSeek R1. So at this stage, what we've used is Tavili, and we've used the DeepSeek V3 model here. And you can see that if we look at the debugging results and stuff like that, we can see the different tool calls, and we can see what's going on for those parts. Okay, now, if we wanted to do the same thing with the DeepSeek R1, it would be great if we could just swap out the model, right? So here is the DeepSeek R1 reasoner model, and I've made it a little bit simpler. We haven't got a tool now. We've just got this thing where we're going to say we want a life meaning structured result back. And this is going to give us a title, a main, and some bullets in there. And we're asking that you're a helpful and wise reasoning assistant. You're an expert in thinking. If you're given a question, think carefully and respond with a title, your thinking, a set of bullet points, and a final answer. All right. And you can see we try it and boom, it doesn't work. And the reason why it doesn't work is the DeepSeek Reasoner, which is the model that we're using now, the R1 model, just doesn't support function calling at this point. So this raises an issue. But if we just get rid of any dependencies going in, and we just run it so it's got no dependencies now, we're just going to get the response back from the model, then that actually works fine. We can run through the same query into it. We can even pass in the exact same system prompt. It's just that we're not putting any input dependencies or result types for coming back from this. So you can see that if we do that, sure enough, the model has actually given us some nice data here. If we look at just the data that came back. Now, the problem is we can't index into this and get our title and our bullet points and the main and stuff like that like we wanted. But we can see that the model has done the work. So we've got the title there. We've got the thinking process that we asked for there. We've got summary bullet points and we've got final answer. So it totally understood our prompt and it totally formatted things for this. The problem is now we've got a few different options. We could take this and we could write some kind of parser, where we do some sort of regex and we look for title or something like that. The problem with that is that it's probably not going to work all the time. It may work a lot of the times with this model being quite consistent, etc. but we're going to run into issues around that over time. So this is where the little hack comes in, is that we can set up another LLM, something that's really cheap, like a Gemini 1.5 Flash, that actually does give us structured outputs back and does give us all those things back. And we can pass in the result type, the formatting for the structured outputs that we want, title, answer, bullets, thinking. And we can give this model a system prompt that you're a helpful formatting assistant. You never give your own opinion. You merely take the input given and convert it to the structured result for sending back. So we're using the Gemini Flash purely as a formatting agent, just for formatting that. So we can take the output that we had up here and we can send that in as the context window for this formatting agent. And you see, sure enough, it will return back structured information. So we've got the structured title, we've got the answer, we've got the bullets, we've got the thinking, and it's split up all of this in here. Now, you might say, okay, but we had to do 2 calls for this. Yes, but the Flash call is going to be very quick and it's going to be very cheap. The DeepSeek R1 is already pretty cheap for doing this. So this is like just guaranteeing that we're going to get a nice structured output of whatever we got back from the actual model. The challenge with this, though, is that while Pydantic will give us back the sort of normal content, it turns out that content is only sort of part of the DeepSeek R1 output. So if we come back and look at the API docs, we can see that the output actually comes back with 2 parts. We've got one part, which is the content output, which is basically the answer. And the other part is the reasoning content. So that's actually all the thinking, chain of thought, all that kind of thing. So really, we would like to capture this. Now, my guess is that could be very quickly that we see Pydantic actually update to be able to give us this back. But it's not a big deal. We can just use a standard LLM call to get this, which I'll show you in a second. Now, interestingly, they've got a whole bunch of things in here of how the actual chain of thought works and why they're returning things like this. If we look at this multi-round conversation, what you would basically have here is we've got like the query input or the first sort of user input. Then it will return the chain of thought back for this query and the answer back. And then if you're doing sort of a multi-round conversation, what you would then do is just pass that in with the next sort of query, and you would get the chain of thought for the second one. So you don't pass this original chain of thought back in again, and it's not going to be giving you that back each time. So this is something that you want to be aware of, that if you want to use that chain of thought, you've got to get it and get it when it comes back and then use it then or store it to use it later on. So what we were getting here when we did the thinking in this case was actually the thinking that just the prompt alone telling it, hey, give us some of your thinking in the answer. That wasn't actually the internal chain of thought. So getting the real thinking or the chain of thought in here, we're going to want to actually extract sort of both of these back, right? We want to get back the reasoning content and the normal content. So you can see here, I've changed the system prompt a little bit where I tell it to, if you're given a question, think carefully and then respond with a title, a set of bullet point summary and final answer. So we're not asking for it to give its thinking anymore. We're just going to take the sort of internal thinking of this. Now you can see we can basically just do a standard sort of OpenAI call to this DeepSeek API endpoint. We pass in the system prompt. We pass in the user, what is the meaning of life in here. You can see we're using the DeepSeek reasoner model. And you can see, sure enough, we got back both the reasoning content and the content. So if we look at just the content, you can see this is sort of the final answer out. And sure enough, it's still got title, it's still got the bullet points, it's still got the final answer. It's not including sort of the thinking in the same way as it did. But now we can come up here and we can look at its internal chain of thought where we can see, okay, so what it did before this was, okay, so the user asked, what is the meaning of life? And that's a big one. Let me start by breaking this down. And we've got like the whole sort of thinking steps in here. If we wanted to extract anything special out of the thinking steps, we could just pass that to a formatting agent to get the things back of, okay, what were the key things that it did for the thinking, etc. Or what I'm doing here is I'm combining the whole thing into something that we're going to send to the formatting agent. So the challenge here is when you combine this, you've got to combine these two strings. You probably want to add a little bit of formatting. So you want to show that, okay, that chain of thought, this reasoning content, I'm wrapping it in the original thinking tags that are very similar to what it was actually using. And when you look at the distilled versions of the model, it uses these kind of things. And perhaps you could make the argument that I should wrap these in the answer tags as well for the final content in there. But anyway, I'm joining all of that. We're putting that back into our Gemini 1.5 Flash speedy little cheap formatting agent. So we're getting the structured results out. And sure enough, you can see we've got the structured results out back now. And we can see that it's now able to work out that this was what was in the thinking tags. And if you compare this, this should be pretty much a direct match for what the model actually did. So with an extra call, we were able to basically take that DeepSeek reasoner and then use it as a fully formatted model out. All right, so the other option that you have is you can use the reasoner model as a tool. So here what I'm going to be doing is setting it up where we've got a orchestration agent, which is going to be the Gemini 1.5 Flash, and we're going to give it tools. So we're going to give it the tool of the orchestrator. We're going to give it the tool of the get reasoning answers in here, which you can see that all this really does is just call the DeepSeek reasoner, gets both the thinking or the reasoning content back and the just answer content back, joins them back, sends it back to the orchestrator. And we've got the Tavili search in there. So by putting these together and giving the orchestrator a sort of sequence of that, we want it to basically get the reasoning engine to come up with the keywords. We want to get the search tool to actually go and get the stuff. And then we want the synthesis done by the reasoning engine. And then just having the formatting at the end, etc., done in here. We can run this through. So I've asked it to basically, please create me a report on the GRPO RL used in DeepSeek R1 0 model. Okay, so it goes off and does a call for each of these. Let's actually go in and have a look at the debugging and see what happens. All right, so in the debugging, we can see we've got our system prompt. And we can see it kicks off, and the first thing it decides to do is get reasoning answers call that as a tool. And the input to that is generate 3 to 5 search keyword phrases for the query. Please create a report on GRPL RL based in DeepSeek, etc. Now, I will show you that actually I don't think this model is great at generating the keywords. We're probably better to use a different model for this. It is interesting though, sure enough, its answer back shows us that it's thinking about it. Okay, let's tackle this query. The user wants to generate a report on GRPORL. Now, the reasoner model itself doesn't know what this is, right? This was created obviously before the R1 model existed, and it seems like it doesn't even know what the GRPO is. It comes up with some different ideas of what it thinks it is. In the end, it decides that, okay, some possible keywords, GRPO, RL, DeepSeek R1, and it's interesting in this case where it's trying too hard to answer the question. It should really just sort of say, okay, here are your keywords, go and do some searches and get me stuff. Anyway, finally it does do that. These go off to the search tool. This goes back to the orchestrator. The orchestrator uses the search tool to go through this for each of these. And then we get like the DeepSeek, each of these keywords basically gets information coming back, which we can see from what we're getting back here. I've probably limited the searches too much, like based on what they did on their page, they're getting 40 plus web pages back. I think I'm just getting 3 for each sort of keyword. Anyway, we can see that it goes through. If we look at their example, we can see that it really understood what the GRPO is. And I started to wonder, okay, how come when I call the model, it doesn't understand it, but when this calls the model, it does understand it? It's clearly because they're doing the search first. And we can see this, that when I do it without the search, it really has no understanding of this. And it comes back goods, receipt, purchase order. And RL could mean reinforcement learning. And it's the same kind of thing as what we've got there. So from that takeaway, I would re-architect this to not use the reasoning engine at the start to get the keywords. I would just basically get another model to make the keywords, get all the search results, and then give it just to the reasoning engine for the synthesis part in here. But the main thing I wanted to show you here is that you can use it as a tool and it will operate as a tool in here. So that's allowing you to get reasoning sort of synthesis in this case back for what it is that you want to be able to apply this to. Anyway, just to finish up, I wanted to show you in this video that even though the DeepSeek R1 model doesn't have structured outputs, doesn't have function calling, you can kind of hack around this by getting other models to help and just getting the DeepSeek R1 to format things out in a way that you can use either a formatting model to do the structured output, or in the case of our final one, the orchestrator to do the output. So it's still really early days of using these reasoning models for agentic sort of applications. It seems to me that they're very good at certain things, and actually for other things, you're really probably much better to go with a simpler model, even if it's like a GPT-4o or something like that. I guess it really comes down to what parts do you want really good reasoning. And in the example that I showed here at the end, it seems like probably keywords, you don't want good reasoning because you don't want the model trying to guess what those acronyms are. You actually want it just to say, okay, I don't know. Here's a search. Go and find out for me, and find out as the real sort of source. And this is a very similar thing that you see with the O1 models as well, etc. Anyway, I'd love to hear from people what people are interested in building with these reasoning models. I'll probably end up building some more things with this and make some more videos over the next few weeks as some of the Gemini models come online and stuff like that. We can try those out as well in a similar kind of way. All right, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.